Now since there are large number, there's a little classification that we will do based on the number of halogen atoms. We can classify them into different types based on the number of halogen atoms which are directly attached to it. So supposing there is only one halogen atom, then we say, for example, CH3, CH2, CH2, Cl, right? So this is a monohalogen derivative. Monohalogen derivative. Vaishnavi, is there a lag in my writing? Are you able to see what I am writing?
Yes, ma'am.
Oh, good. Now, supposing there are two, this is CH, and I remove, I put two halogens on it, CHCl2, right? It becomes a dihalogen derivative. And if I take, say, CHCl3, this is chloroform, this is a trihalogen derivative. Right? So this is one classification. You could have a tetrahalogen derivative also, carbon tetrachloride. So this is tetrahalogen derivative. So we will learn, I have mentioned a few which you will come across. This carbon tetrachloride, it's a very, very good solvent. You will learn about carbon tetrachloride also. It will be mentioned, or you'll come across. In many reactions, we use carbon tetrachloride as a solvent. Okay, so this is what I have written. These names we will learn once again. So monohalogen, dihalogen, trihalogen, and tetrahalogen derivatives. Now you will have to learn the classification based on the nature of carbon atom to which the halogen is attached. Okay, so let me just draw one, not okay, this is just a hydrocarbon that I have drawn. Okay, now in this hydrocarbon, I have deliberately chosen this hydrocarbon. It is 1, 2, 3, 4, 5. I hope you remember the nomenclature. So it is 2, 2, 3 trimethyl pentane. Now I want you to identify each carbon atom. You look at it closely. The first carbon atom, it is attached to only one other carbon atom. This is I will number these carbon atoms. So the first carbon atom is attached to only one other. I have numbered the 4 carbon atoms. So the first carbon atom is attached to only one other carbon atom. And so I can give it a name. I can call this first one is called primary carbon. So the carbon which is attached to only one other carbon atom or no other carbon atom is a primary carbon. Now from that definition, Hari Raghav, can you give me the answer for the next question that I am going to ask? What about the second carbon atom? What will I call the second carbon atom? First one is primary. What is the second carbon atom? Hari Raghav, can you tell me?
It is attaching with 2 carbons.
It is attached to 2 other carbon atoms. So what will I call it?
Secondary carbon.
Secondary carbon. It is a secondary carbon atom. And Vaishnavi, can you tell me what about the third one?
Ma'am, tertiary.
Tertiary.
As it is attached to 3 carbon atoms.
Tertiary carbon atom. All right. So you very nicely recognize primary, secondary, and tertiary. The fourth one is quaternary. We don't need it right now, but you need to understand primary, secondary, and tertiary carbon atoms. So depending on where my halogen is, I could have a, so if my halogen here, if my halogen is attached to a primary carbon, it will be a primary alkyl halide. If it is attached to the secondary carbon, it will be secondary. If it is attached to a tertiary carbon, it will be tertiary. Okay. So let us take an example here to understand it better. So I'm going to take an example of an alkyl halide. Before I'm looking at those alkyl halides which are monohalogen derivatives. Okay, so which have only one halogen. So I'm going to take the example of C4, H9, and Cl. And I want you to write down different possible isomers of C4H9Cl. Okay, so let us write 4 carbon atoms straight. Write the isomers of C4H9Cl. 1,
Ma'am, we can fill the hydrogen in all 4.
yes, please fill.
Okay.
If you don't fill also, it's okay. If you know how to fill, that is good enough. Doesn't matter. Now I'm not looking at the hydrogens. I'm just looking at you to identify. The purpose here is to identify a primary, secondary, a tertiary alkyl halide. Okay. Now the first one, Tejas, the first one, is it a primary or a secondary or a tertiary alkyl halide? Tell me.
Ma'am, it's a primary carbon.
It is primary. Very good. This one is primary. Okay. Hari Raghav, the second one here, is it a primary? This is 1, this is 2, this is 3, this is 4. Hari Raghav, second one is?
That is secondary.
Second one is secondary. Very good. And the third one, Tejas, the third one?
Ma'am, tertiary.
I knew you will say that. Now look at it. Look at it. Hmm?
Secondary.
No. Hariharan?
Primary, ma'am.
It is primary. It is primary. Now see carefully. The carbon, I told you, the carbon to which Cl is attached. You have to look at that carbon. So this carbon here, it is attached to only one other carbon atom. So it is a primary alkyl halide. Do you understand? So it is a primary alkyl halide. And
the middle carbon attached to 3 other carbons, right?
Yeah, this carbon, the middle carbon is attached to 3 other carbon atoms. So the middle carbon is tertiary, but my halogen is attached where? It is attached to the primary. It is not attached to the tertiary. Now they just look at the fourth one. Fourth one is the tertiary alkyl halide. Now can you distinguish? Did you understand the difference?
Yes, ma'am, because the chlorine is attached to the middle carbon.
Yeah, chlorine is attached to the middle carbon. So you have to carefully see whether your chlorine is attached to the primary or secondary or tertiary, then decide what type of alkyl halide is. So this is the second type of classification, which is based on the nature of the carbon atom to which your alkyl halide, halogen is attached. So based on that, they could be primary, secondary, or tertiary carbon atom. So this is just in a form of a slide. Now there is one more classification, and that is based on the hybridization of the carbon to which halogen is attached. Hybridization of the carbon. So normally you would have learned, you know, the hybridization, right? So if the carbon is, has all single bonds around it, like if it is an alkane, right? Then this carbon here, what is the hybridization of such a carbon? Anyone? Hariharan, what is the hybridization of a carbon atom which has all single bonds around it? What is the hybridization?
sp3, ma'am.
It is sp3. And if the carbon is involved in a double bond formation, then what is the hybridization?
P2, ma'am.
sp2, right? So depending on the hybridization of the carbon atom to which halogen is attached, also we can classify. So if the carbon to which halogen is attached is sp3 hybridized, like in case of alkyl halides, then they are called alkyl halides. So if I have CH3, CH2, and Cl, then this carbon is sp3 hybridized, and these are what we learned till now in the previous examples. All were what? Alkyl halides. In the previous page, the examples that we learned here, each carbon atom here is sp3, because all carbon atoms on which halogen is attached, they are all sp3 hybridized. So they are all alkyl halides. So we learned alkyl halides. Now we have to look at other carbon atoms. Supposing there is, I will take a slide and explain, and we will come to this slide. So if I showed you already, if they are all single bonds and halogen is attached here, then it is alkyl halide. Now supposing the carbon atom is sp2 hybridized. So there are different possibilities. Supposing I have my benzene ring, you have learned already in 11th standard that in benzene ring there are alternate single and double bonds. So my halogen is attached here. Halogen is directly attached to a carbon which is a part of the benzene ring, right? So when halogen is attached directly to this benzene ring, this carbon atom now is sp2 hybridized, right? So this, among those, the first example, these are called aryl halides. I need the charger. So these are aryl halides. Then supposing I have CH2 double bond CHCl. If it is a part of the benzene ring, I call it aryl halides. Now this one where halogen is also, it's an open chain, but halogen is attached to the sp2 hybridized carbon. This one is called vinyl halide chloride. Vinyl chloride I will call, because here it is halogen is chlorine. So vinyl. There is one more possibility. That is, I take CH3, CH double bond CH2. What is this compound? Tell me. This is propene, right? This is propene, right? So what I do is I will attach my halogen here. CH2 and halogen is here. So it is attached to the sp3 hybridized carbon, but this carbon is adjacent to a sp2 hybridized carbon. This is allyl halide. Allylic or allyl halide. Okay. Another example of this one is where you have a benzene ring, I mean like a cyclohexene. So this carbon, these two carbon are sharing the double bond. If my halogen is here, this is also an example of allyl halide. Okay, so when halogen is attached to the carbon which is sp2 hybridized adjacent to the carbon which is sp2 hybridized, then it is called a allyl halide. Then there is also one more type. When on the benzene ring there is a carbon atom attached, this compound, can you tell me what is the name of this compound? This is toluene. And on toluene, if I take the carbon side chain and I put here, so it has a benzene ring, but halogen is not attached to the benzene ring, but to the carbon side chain, then it is benzyl halide. This is benzyl chloride. Okay, so you could have a benzyl, a allyl, a vinyl, a aryl, a 5. You should be able to identify 5 different ones. Alkyl is when there is an alkane which is substituted and one halogen is attached. Aryl is when it is directly attached to the benzene ring. Benzyl is when it is on a carbon side chain. Allyl is where you have on the adjacent to the sp2 hybridized carbon. And one is, of course, vinyl when it is directly open chain, but directly on the carbon atom, which is sp2 hybridized. So these are different types. So alkyl halides, allyl, benzyl. So alkyl, allyl, and benzyl, they are sp3 hybridized carbon, but halogen is attached to sp3, and in different conditions are there. This is sp2, vinylic, and aryl. So I hope you have understood. With little practice, you will understand.